Now that we've talked about concurrency and scheduling with RxJava, we can continue on talking about some other methods that leverage the ability to run computations in other threads and other concurrency contexts. And we'll start by talking about some other factory method operators. And these factory method operators create observable streams in various ways, and they go above and beyond what we've seen earlier with things like just and from callable, from iterable, from array. And the three factory method operators we're going to look at now are called create, interval, and rangeLong. So what does the create operator do? It creates an observable that can emit multiple elements either synchronously or asynchronously. So it can either run in the calling thread or run in a background thread. The parameter that's passed to it is something called observable on subscribe, which is a bit of a mouthful. And it's a functional interface that has a subscribe method that receives an instance of something called an observable emitter. And we'll talk more about what an observable emitter is in just a bit. Observable emitter can emit events using various methods like onNext, onError, and onComplete. And what's cool about it is that these things can run in a different threading context and emit them to go back up through the stream. And therefore, you can use create for much more dynamic use cases than the simple factory method operators we talked about before, like just, from iterable, from array, from callable. So it gives you more flexibility to do a wider range of things and kind of chain stuff together in different thread contexts. Create returns an observable that emits all the elements that are generated by the observable emitter. So the observable emitter is kind of a generator that generates events, and then they're going to be handled by the observable that's returned from create. These elements from the emitter, observable emitter, can be emitted from one or more threads. So let's take a quick look at this example here, which we'll take a look at in more detail when we get to the case study. This emitter, which is called emit interval, actually uses a background thread to emit events, which are then handled in the fluent method operators that I don't show here with the dot, dot, dots further down in this chain. Project Reactor has a flux create operator that works in a very similar way as the create operator on RxJava's Observable. However, it's even more complicated. So there's even more stuff going on, and I won't talk about that in this context, in this class, but if you take the reactive microservices class or scalable microservices class or whatever we call it, the class I'm teaching next semester will cover that in much more detail. Both of these methods are somewhat similar to the generate method that's provided by Java Streams. They're not identical, but they're sort of along the same lines. Generate isn't quite as powerful as these methods because in particular, you can't control where it generates stuff as easily, as flexibly, I suppose, as RxJava and Project Reactor. This particular example generates a stream of random large and unreduced big fractions, and it'll just generate that until the cows come home. It'll never stop generating those things. Let's now turn our attention to another factory method operator, which is kind of cool, and it's called the interval operator. And what it does is it creates an observable that emits a stream of long values starting with the value 0. And you can tell it how frequently to emit the values. So it's basically a timer that's like an interval timer that will emit these values at the intervals specified by this timer, these parameters. So you can say how long between each emission and what the time unit should be. Should it be seconds? Should it be milliseconds? Should it be microseconds? And so on and so forth. It returns a new observable that emits these numbers at the regular intervals that were specified here. By default, or not by default, by design, the interval operator emits the values using the scheduler's computation factory method. So it's this factory method, scheduler's computation, that returns a scheduler. And this is a default pool of threads, typically going to be associated with a number of cores on the computing device. And that runs in the background and is expected to be used for CPU-intensive or computation-bound tasks, not intended for I/O-bound tasks. As it says here, it's not recommended to perform blocking I/O work on the computation scheduler. Use the I/O scheduler instead. There's other overloaded interval methods that can designate the specific scheduler to use. So you're not stuck only using the scheduler's computation scheduler. But that's a pretty darn good scheduler to use because emitting events at a regular interval is really not an I/O-bound operation, so using that thread pool is as good as anything. Under normal conditions, the observable never completes. What does that mean? It means that you go ahead and say, I want to generate events starting at 0 every half a second, so every 500 milliseconds. And that will run in a background thread from the computation pool. And that'll just keep going forever. You typically don't want to run it forever, of course. So you can bound the amount of time taken to run by using something called the take operator. And that's an operator we'll talk about later that can suppress data. And what it's going to do is this particular use of take is going to only emit the values from 0 to whatever for S max iterations, whatever that constant is set to be, or variable for that matter. So because you can change that value dynamically depending on how you initialize it. Project Reactor has an interval operator on its flux class that works exactly the same. And once again, we're using take to process S max iterations of values emitted every half a second. This is the way you do it in Project Reactor. It's a little bit further down the line, so it uses the duration class I think that came in Java 8 and beyond, whereas the interval stuff uses this approach with a time period and a time unit. There is really nothing quite identical to interval in streams, although I suppose you could use generate with a sleep call in order to generate things at an interval. The last method we're going to talk about here in this turn of the crank discussing factory methods in the observable class is the rangeLong operator. And this will build an observable that only emits a sequence of incrementing longs from start to count. So it emits longs between the start value up to the count, and then it completes. Start is included in the range, so it's up to and including the count. It returns what's known as a ranged observable that will contain the count number of elements that it needs to process. You can think of rangeLong as working much like a reactive for each loop or a reactive for loop, in that you can basically say for notional I equals 1 to I is max iterations, keep looping and generating these events one at a time. So it's kind of the functional way of doing a for loop. Project Reactor has a range method on the flux class that works the same way. It's actually quite identical. Oddly enough, there's no rangeLong method, however. So it'll only generate integers, and if you want to create something that's a long, you have to explicitly use a conversion operator to convert the integer to an unsigned long using map. So a little bit curious. I'm not quite sure why they didn't add that feature, but you can always make it work by using an adapter like we see here. Both range methods in Project Reactor and RxJava are very similar to Java streams. Range close method defined on int stream or long stream for that matter. So here we're going to be able to once again emit S max iterations starting at 1. So same basic kind of idea. So that's the end of the next discussion about factory method operators in the observable class. And you can see these are a little bit different from the simple ones we looked at before. They give you more options. And if you build non-trivial applications using RxJava or reactive programming, it's worthwhile knowing how these things work.